Yeah, hi everyone. Thank you for coming to our workshop. Please remember to sign in. So today we're going to be learning how to implement the game Snake in Python using Turtle and Replit. If you don't already have Replit account, you can go to their website and sign up for one. The code might work elsewhere, but like some of the function calls might be slightly different. Yeah, there's a link to Replit in our slides, and in order to do this project, you want to create a new REPL, which is with Python, but like including the turtle function. It's a little bit different. Yeah, I might just leave this slide up for a minute, or maybe actually you can probably go back to it too. But yeah, that's like where we're going to be building off of.
Okay, so we're going to be using the Turtle library, which is a graphics library that you can use to make so-called turtles. So from like how you can understand this is imagine like a turtle at the 0, 0 of your coordinates plane, or like the origin, and you can give it commands like turtle.forward, which will tell it to go forward, or turtle.right to tell it to go right. So it's like a really intuitive way to understand like graphics and make things move with this library. And so we're going to use it today to make a snake move. And so like here's like a picture from their documentation, which is of a turtle drawing intricate shapes using programs that repeat simple moves. So they can just send a shape moving in these directions without clearing the screen, and you'll end up with a fancy little star. So like if you just send your shape moving in that series of directions. So first we're going to go over some helpful functions that you'll see. And so a lot of these this is from like the actual snake code. We're going to provide some of it. And so the first line is snake equals turtle.turtle. And what that tells you, the first turtle is referring to the library turtle that we are going to import. And the second .turtle tells you to create an object called turtle. And I don't know if all of you are familiar with like objects. And I know we didn't go over objects in Python, but if you're taking CS31 or 32, it's like the same idea of classes. So you're creating like an object that's of this class. And for that, after that, you can change properties about it using these functions associated with the class. So first you can do speed and set the speed of the turtle object, which is going to represent the snake. So we called it snake, to be 0. You can change the shape to be a square. And there's other possible shapes like circle and stuff like that. You can change the color using the .color function, which you can specify colors like simple colors like red, blue, white. You can also provide a hex number in the parentheses. So like you can look up hex numbers to represent different colors and put in your parentheses to change color around, which is kind of cool. You have the pen up, so it makes it seem like the turtle doesn't draw. So it's like raising your pen literally from drawing. Snake.goto will send your snake object to the certain location. So like you're telling it right now to go to the origin. And then you can also give it a direction. So you can give it a direction to go up, down, left, right. So it's like facing different orientations. And you can also tell it to stop. Okay, and then there's a bunch of other functions for moving our turtle. So there's the snake.x core and the snake.y core, which gives us the x and y coordinate of the snake where the snake is currently at. So like if you've done object-oriented programming and you've heard of like get and set functions, these are like the get functions to figure out the coordinates associated with this current object. And you can also tell it to go forward and backwards. So like what I said when I introduced it. So like imagine you have like a snake or a turtle and it's at some coordinates. You can tell it how much pixels you want it to go forward using the forward and backward functions. And it's going to go forward at the speed we set earlier. So like we set a speed in the last slide and it'll go at that speed and it'll go the distance you specify. You can use snake.right and snake.left to just rotate the snake by the angle you specify. And then I think we had snake.goto on the other side, but that's also just moving it to the location you specify it. And then here at the bottom, we have the set function. So that's kind of again, like how I said, like the get functions. These are setting that just either an x coordinate or a y coordinate and leave the other coordinate the same. So like if you wanted to move from 0, 0 to 0, 1, you could either go to 0, 1, or you could just set the y coordinate to be 1. Okay, and then we can, so if you wanted to use our turtle objects to start like actually drawing them or moving them around, we can create this object that's a marker. So there's a couple different functions and they also go by multiple names. So you can do like a pen down to tell the marker to start drawing, pen up to tell the marker to stop drawing, and that kind of makes sense because of like just bringing your pen up and down. You can specify the pen size or width. You can specify the pen color, and again, you would specify the color using either like the string red in quotes or like a hex representation. Or they'll probably accept other parameters if you check like the actual documentation, which we have linked on slide 3. And then you can also clear what the marker has already drawn. So that's like clearing, just clearing whatever the marker is drawn. And you can also hide it by using the hide turtle function. And then on the bottom line, this is for writing text. So this is going to write out the score and it's going to format it. It's going to format it, aligning it to the center. You can specify by the font, so like Courier 24. And then you can also specify like bold, and that'll just write the score to the screen. And notice how when we specify the font, we are using like a tuple. So we're seeing that as the way some of these functions work is that you'd have to check the documentation, which is not like hard at all to read, and see how it wants the parameters to be. Okay, so then here are some functions to control our screen. So if you make a screen turtle and you use .on key, what it does is where the call this function goes is you put a name of a function you defined. So like I could define a function called move, and I define that using the def statements like that you would have seen before whenever you're defining your own function. And then what that does is whenever you push the up arrow, it'll call the function you tell it to call. So like it'll be automatically called. So it's like a way to just make sure that like it's a way to take your user's input and do something with that input. There's screen.background color or BG color, which will just set the background color. There's screen.listen, which tells the program to pay attention for keyboard inputs. So you can do that, and then you can, after you listen, you can do, it'll know what to do on each key call because you use the on key command. So let's say like you did the on key, you told it what to do when you do up, and you told it to go like 10 pixels up. You give it a function that tells it to do that. What it'll do is after it listens, and if it sees that you push the up arrow, it will call that function and do what you wanted it to do while it's listening. And then screen.update just updates the screen with changes. So one of the things we'll be doing in this snake game is, as you've all probably seen, like snake game, they have the little fruits that you're going around collecting as the snake. And what we're going to do is using random numbers to generate. We're going to use the random library to generate these random numbers to put these fruits at random places all over our screen. And so we'll use that to get a random number in a certain range, which is helpful when picking a new location to send something to. So here's an example of the first random says that we're using the random library, and then the second function is the second part after the dot is the function itself, which is a randint function, and it takes the range. So this is like the start value, and this is the stop value of where to pick a new number between. And then some other functions that are helpful. You have the distance function, so that so it's actually a function of a turtle object. So like turtle 1 and turtle 2 are two turtle objects, and they each have like their x and y coordinates associated with them. And using the distance function from one to the other just tells you the distance between the two. And notice that you have to call it using the dot syntax. So like you're calling it on. It's like a function called on an object, but you pass it another object as a parameter.
Yeah, so now I'm going to be, so like before we go through the how to like we can actually code this. Are you guys like wanting to maybe try? So we have pseudocode linked in the links. We have it in Google Colab. It can't actually run in Google Colab because it's like Turtle's kind of weird in that. But like if you create a replit, you can just like copy and paste into a blank one, and then from there we can like gradually code it together, or like if you guys want to say maybe try and use some of these functions to like code it yourselves, like anyone have a strong preference?
Can you go over the options again? Sorry.
Oh yeah. So we have our pseudocode, which you can like put into a blank replit, and like we're wondering like do people like want to like try doing it for themselves first, or like we can also just go through it gradually as like a group and then talk about implementing different things.
I don't know. I don't have a strong preference. Either is fine for me.
Should I do the poll?
Yeah, maybe do the poll.
I'll launch the poll. This is from a different workshop, but yeah, just this is kind of covers the different options. If we do breakout rooms, we'll come back and reconvene probably. So like it's not just breakout rooms only. And like you can also work together to code it, so like someone can share and someone like you can talk together if you want. If that sounds fun. I don't know. Up to you.
Okay, yeah. So I guess
Do you see the results too?
I'm going to go ahead and end the poll. Looks like we should be demoing it. Yeah.
Yeah.
Okay.
We can also do breakout rooms after a few sections and check if people want to do breakout rooms after we do a couple of them together. Yeah, I don't know. You can take the way.
Yeah, so like for starters, in our pseudocode, we have it broken up into like part A, B, C, like relating different places in the code and like what we kind of want to do. So for our part A, which is here, we want to initialize. Oh, it didn't get marked up, but yeah. So basically, this up here, we want to initialize a fruit, kind of like how we initialized this snake, and put it a location that's on the board in order to start with. Does anyone like have an idea of like how we do that? Maybe doing something very similar to the code for the snake. Like yeah, just for start, like just to initialize it, we could.
Isn't it fruit is equal to turtle parentheses?
Yeah, that would be exactly how we would want to first of all initialize it. Like that. And then we also generally want to assign it a shape, color, initial location. So we can say, so we would say fruit.shape, oops, since we're calling the fruit object, and then we want to call its shape function, and then what we could say circle. And then that would give our fruit turtle a circle shape. Besides that, we also like want to do a color, initial location. So like we have for the snake color here, we can say our color for it is we can say red. And then we also need to assign an initial location. So does anyone know how we could send it to a place?
We would do fruit dot go to the X and Y location.
Yeah. So it doesn't really exactly matter where we send it for this first, because this is just setting the initial location. So in the future, we want to send it to a random location, but for here, we could say maybe do a predetermined one. So like something that's not 0, 0, we could say maybe 30, 30. In addition, we have for our snake a couple more initializing things, speed of 0, pen up so it doesn't draw, and direction. So we can kind of copy that, do something like that too, just to make sure it doesn't do any strange things. Yeah, I think that's all we need, although we should actually do the pen up before we say going to that location so it doesn't actually accidentally draw a line. Yeah. Okay, so we made our initial fruit. Going through the code, there are more Toto things. We also need to make sure that we're doing key mapping for input. So that way, if we're pressing a certain key, it's going to cause a certain function to happen. We have some things about key mapping here, this on key function, and we actually end up calling it in this code. I think it's down here. These are like already mapped out and telling it to listen in general, but we don't have these functions defined. We have our go up function here, but we don't have go down, go left, or go right. So we need to like say what we want to happen when these down, left, and right arrows keys are pushed. For that, for our game, we generally want, like if we say we wanted it when we're having an arrow key pushed, we want to change direction unless it's facing the exact opposite direction, therefore can like only turn side to side or like continue going one way. Like, do you know how we would implement that here? Okay, yeah, sorry. Yeah, so when we have our on key function maps when we see a down input to this go down function. This go down function hasn't been implemented yet. So what do we want to happen when we're pressing our down key, basically? And then we should make a function to do that. Yeah, it is like that. We might also like say if our snake's direction is not equal to up. So that way it doesn't go. So that way it doesn't, if we're going up, it can't like immediately turn 180 degrees and run back into itself. But yeah. Then we do want to set our direction to down if we're pressing our down key. And then likewise, for our go left and go right functions, we kind of want to implement something similar. So we can say if our direction is not, in this case, go right, which is the opposite of left, we want our snake to start going in the left direction. And then finally,
colon. I forgot the colon. If statements.
thank you. Yeah, and then finally, if our snake's direction is not going left, we want it to turn right. Yeah, so that should allow our key inputs to be mapped to what we want them to generally do for our snake. Does anyone have any questions about what's going on? Pace, anything?
Did people understand why we had all the if statements in there? Also the colon again.
Yeah, so basically, so for our key mapping things, if we're pressing this, it just tells it, like if we're seeing the up key, down key, whatever, then it automatically calls these functions. So then we have our if statements because in a snake, we don't want to turn 180 degrees back. So we should say, oh, if it is going up, we don't want it to immediately go down. This basically checks the current direction.
It's like when you're playing snake, you can't actually turn straight around. You have to go. You have to keep going. If that makes sense. We didn't have a picture.
Okay, yeah, cool.
But you can't turn around.
Yeah. So that takes care of setting things up. Now into the more main control thing for our game. So basically we have this variable saying to keep on repeating this code while our game is ongoing. So first of all, updating the screen, and then next we want to basically make some code that says if our snake is touching the fruit, what's going to happen. And in snake, that means that our snake is going to grow. And how can we implement this? Does anyone have a guess about how we can maybe make an if statement that is detecting if the snake is touching the fruit?
I think we have the turtle _1 dot distance turtle _2.
Yeah, exactly that.
There's also some in the chat, but yeah, I guess there's a couple methods to do it maybe.
Yeah. So if we could check, if we check the x coordinate and y coordinate, I think that would be, it's more perfectly overlapping, which could be something, but it might be very annoying to get it to perfectly overlap. So that's where you might be more interested in the distance between them is less than something. So we could say if the distance from the snake to the fruit is, say, maybe less than 20. Like 20 chosen sort of arbitrarily. You can test it out and try different things if you want it to be a little bit further away or closer. Then what do we want to do after that? We want to send our fruit to a new random location, and we want to increase our score, and then basically update the score on the screen. And then we want to basically grow the snake's body. Does anyone know how we can like maybe generate some coordinates so we can send our fruit to randomly? Yeah, exactly. We can call our random function. So I think the coordinates in the slide were ones that worked with the dimensions of our screen. So this is like just the way it's chosen. We can, like, depending on the size of the screen, we can choose different coordinates. Wait, did I? Yeah, I think these our coordinates are wrote down for just making sure that's within bounds, so we can just with regards to the screen, so we can wait. Sorry. So we can say our y needs to be within that range, and our x should also, we can also generate a random one for x to be in, which can be between say like 290 to 270. And then we need to send our fruit to these to this new location. So does anyone know how we could do that?
Fruit dot go to and then x
Yeah.
y.
Yeah, exactly that. In order to send our fruit to that new location. In order to increase score, we can just say score is our old score plus 1, which we have because we just intersected that fruit. And then afterwards, we need to, we don't really need to make a new fruit exactly, but we need to grow the snake's body. So we already have this array, or we actually, no, we do need, yeah, so we need to make a new fruit and add it to our old fruit array. And our old fruit array is basically the body of the snake. So we kind of want to call it with similar things like we were setting up fruit. So we can call this our new fruit. Just to initialize it. And we also just generally want to set up its speed and shape and all that. So we're using code here. We we can have it, maybe its shape be a square, so that way it matches the rest of our snake, which is square. And then we can have the color is fine with being red, that way it can look different. And we should make sure that we lift its pen, because otherwise it will draw on our board, which would not be good. We should also have its speed be 0, because we don't want it to be moving around. And then we need to afterwards add this to our old fruit array, which is going to be the body of the snake that's falling around. So we can do that by saying old fruit dot append to add it to the array, and then our new fruit that we just created. Does that kind of make sense? Does anyone have any questions about that and what's going on?
I'm a little bit confused by the pen up function. So if the pen is up, then it's just the fruit is just traveling, but if the pen is down, it's making a line as it's traveling?
Yeah.
Okay, got it. And then I had another question. What if the new fruit had a different speed than the fruit and you appended them together? What would happen?
I'm not sure exactly. I think it mainly matter if you're telling it to go forward, and it would just affect, I think, the way it would transition, how fast it would move across the screen. But I think we're mostly using go-to functions, so I think it wouldn't be affected as much.
Okay, got it.
But yeah, you might have to double check the documentation. Okay, so we have a condition for if our snake is touching the fruit, which is one thing in the game. Another thing in the game is every single time we go through our loop, we want to update the location of the snake. So in order to do that, we need to do several things. We need to move old fruit, which is basically the body of the snake, to the next one's location. So basically kind of imagining the inch nail long. We want to update each one to the previous location, the next one. Then we need to, at the beginning of the array, we need to move the first element of old fruit to the location that the head of the snake is at, which is our snake turtle. And then we need to move the snake turtle to its new location. So in order to do that, send each fruit to the next one's location, does anyone know what kind of thing we might want to do? Possibly would we want to do a loop here? Since old fruit is basically an array. Is there a type of loop that people think might be helpful for this?
A for loop? Maybe?
Yeah, a for loop would work great. So we can say for index, wow, that is everything, in, and then some kind of range. And we want to iterate over this array. So our range, we kind of want to start at the end of the array and then go forward because we want to move the last one to the next one's location. So we could go backwards. So this way, by saying the length of old fruit and then -1, we start at the second to last location in the array. We want to go until location 0, but not doing location 0 exactly, because then we want to do something special for the last element in that array. And then we can do a step of -1 in order to go backwards as opposed to forwards in numbers. Does that kind of make sense for how iterating through that? Okay, cool. So then we want to basically read what location this old fruit is at. So if we say our x is our old fruit's x coordinate, and then we could say our y is old fruit's y coordinate. So for that, we're looking at basically the next item up in the array, and then we want to send our current one to that location of the next one up. Does anyone know like what function we want to use to do that? Yeah, go to. So we can say our old fruit of this index we are working on, we want to go to this x and y. Does anyone have any questions of about how this for loop will be basically moving the snake forward? Okay. Well, yeah. In that, so this for loop basically moves everything except for the basically first element in this old fruit array. So we want to move that one a little bit specially because we want to move that one to where the head is currently and we're about to move it from basically. So we can just have this if statement to make sure that our old fruit does have something inside it so we don't accidentally something that doesn't exist somewhere. And then we want to move it to our heads location. So this would be kind of similar to this. Does anyone know how we'd read the x coordinate of our snake?
There's a comment in the chat about how it should be old fruit bracket index.
Oh yes, that is
correct.
That is correct. Thank you for catching that. I'm very human and don't know how to read my own writing sometimes. Yeah. Yeah, we can say x is the x coordinate. for that. And then likewise, we can say y is the snake's y coordinate. And then we want to send our first element in this array to this x and y. So we would just do that like this. Yeah, exactly what Enrita said. Like, it doesn't matter what exactly we're calling this. It's just basically temporary variables, and we can name it whatever we want. And then finally, we want to move the head to its new location. So we actually have this inside this move function where it's not completely defined yet. So what we currently have is y should be its y coordinate, x should be its x coordinate, and this is its current one, and we want to update it. So we can update it by seeing what direction it's in and then just moving it forward in that direction. So we currently have it for up, but we need to do the other 4 directions, which were the other 3, which are down, left, and right. So does anyone know how we would want to maybe try implementing that? Yeah, exactly. So if our snake's direction is down, then we should oops, just happened. Yeah, then we should set its y direction to be y minus 20, which is the opposite. So that makes sense. And then we also want to do our direction is right, and if our direction is left. So for our left and right, we want to be setting our x, and then for right, we probably want to be adding 20. So very similarly, and then for left, it should be subtracting 20 since we're going down in the x direction. Does anyone have any questions about how that's implemented, like what's going on? Okay, cool. Yeah, so next we want to basically be going back to our main loop, and what do we do if our snake goes out of bounds? Like, we need to call an endgame function, but like, how should we check? Like, do we want to check if the head's meaning condition, if the body's meaning condition? Does anyone want to put any ideas for like what we might want to check in the chat? yeah, we should be checking the head's location. So I think with our current size of this screen, we want to have our x between -300 and 280 and y from -240 to 240. Like with different size screens, that could be different things. And like, we just kind of drew a screen that was up here. You could draw a different sized one, and then you might have to change numbers. But yeah, so we could say we want to check the snake's x coordinate and y coordinate. We can do that by saying our snake x core, in this case, is bits greater than 280. And then in order to like check more than one condition, we can just do or between them. So if our x coordinate is less than -300, or if our snake's y coordinate is bigger than 240, or if our snake's y coordinate is less than -240. Wait, parentheses. Does anyone have any questions about that, like how that's working? Okay, cool. Yeah, so made this end game function up here, which writes a game over thing and hides our fruit. So that would probably be a cool thing to call here. And like if you wanted to like have it end differently, or you would just be able to modify this function here. Yeah. And then finally, the other condition which could cause the game to lose is if the snake runs into its own body. So do we want to just do an if statement, or do we need to do some kind of loop? Like, what might be a good thing to like check and see, like, if is the snake coming in contact with its own body? Like keeping in mind that our body is like this array of old fruit. Yeah, a loop would probably be pretty good to do this. Yeah, exactly. Like we want to do a for loop through our array. So in order to do a for loop, we can just say for for any kind of temporary variable name. We just say for f in old fruit. And then for each one, we want to check if it's overlapping. So we could say if the head coordinate equals the array coordinate, but like since these things are not like points, it might work a little better to like say, oh, if its distance is less than a certain from another distance. So like we kind of established 20 up here is being this arbitrary distance away where it would be touching the fruit. So we could like say something like that here. So if this different thing's distance from our snake is less than 20, then we should call our endgame function. Does anyone have any questions about how that could work? Okay. Yeah, if there are any questions, I think that's pretty much it. We can now test out our code and see if it runs. Okay, hopefully it does. Okay, so yeah, that input on line 89, going to that, oh, missing a semicolon. It'd be like that. Okay, indentation error, line 147.
I think you need to indent end game too.
Oh, okay. Yeah. So now it looks like it's been running. So clicking on this, controlling with the keypad, it seems to be working. Okay. Yep, and when it went out of bounds, it called that.
And you can make it look prettier by changing the colors and stuff if you wanted, because the default colors aren't the nicest.
I think there might be some bugs with it still deciding to move,
Oh,
but besides that, it looks okay. But yeah, so does anyone like just have any questions in general, like about anything?
I can stop the recording too.
Yeah, go ahead and do that.